So in this section, we're going to be discussing trigonometry of right angle triangle, right? And what this topic tends to explain is the relationship the size of a right angle triangle has with the respective angles. And that is actually what we're going to be reviewing in this section, which we already know that one side is 90 degrees. And then we also have two other angles. And in this case, I'm going to represent them with the Greek alphabet. This is theta, and this one is phi. So, now, assuming that we're considering this angle, right? All we have to do, we already know that this side is the hypotenuse. But if I'm considering this angle, right, then this has to be my opposite angle. Just very soon I'm going to show you how this formula, why it's very important that this formula I'm about to give is should be applied. And just taking it step by step, not to rush things. Now, if I'm using this angle and I'm considering it, the best way to explain this is for you to imagine that this is an eye, right? Because sometimes it's very difficult for you to know which side is the opposite and which side is the adjacent. But the best way to relate to that is to consider this to be an eye that is viewing. If this is an eye that is viewing, then the side that is seeing should be the opposite. So in that case, we have that the trigonometry, we have the formula called SOHCAHTOA. SOHCAHTOA. And in this case, it says SOHCAHTOA, how to apply it is saying that sine theta must be opposite over hypotenuse. Opposite over hypotenuse. In this case, if I'm considering theta, this must be the opposite, which is A, all over the hypotenuse, which is C. And then cos is saying adjacent over hypotenuse. And I'm also considering, if I'm considering this angle, cos theta, which is adjacent, this is B all over C. And then the last one is tan theta, which states that opposite over adjacent. So I'll just say tan theta, opposite in this case is A all over B. And now let's also look at this diagram through the angle of phi. So in this case, if I'm considering phi, right? And now, this is an eye looking downwards of phi. Now, applying SOHCAHTOA, I can then say that sine phi, remember I'm considering this angle, phi, which is opposite over hypotenuse, in this case, by opposite becomes B, and the hypotenuse becomes C, and then cos phi says that adjacent over hypotenuse, and then tan phi, which says opposite over adjacent, tan, which is opposite, B all over adjacent, which is A. So the reason why I took some time to explain this is it is important not to memorize these things, but to know how they really work, because at some point it gets more complex, and that way you can easily figure out how to manipulate your solvings and work around a complex diagram in geometry. So in this section, we're going to apply the formula or what we've explained in the previous section to solve this. Remember, in this case, I can't just go straight ahead to apply the Pythagorean theorem, because if I should apply the Pythagorean theorem, actually states that in this case, I will need to find at least, had it been that two sides were given in this diagram, then it will be easier for me to apply the Pythagorean theorem. But in this case, only one side is given, and then an angle, one of the angle of the triangle was also given. And because of that, this is where trigonometry comes in, because trigonometry gives us the relationship, or it explains better the relationship that sides of a triangle has with the angle, right? And also to apply this, I've already said this must be the hypotenuse. And in that case, then for me to find, let's find B first. And then I give SOHCAHTOA is more like a general formula. SOHCAHTOA, like a general formula to help you remember this without really cramming it. Just remember how it works. So if I'm to find this and this, the formula that connects this guy, this, and this must be sine. So, which is this opposite and hypotenuse. So sine, which is equal to sine 30, which is equal to opposite of a hypotenuse, and then I have 5 all over b. In this case, when you punch it in your calculator in degrees, you find out that sine 30 is 0.5. Then I can then say 0.5, or you can say 1 over 2. 0.5 is equal to 5 all over b. And then you cross multiply such that b must be 5 divided by 0.5. And in this case, my answer should be b is equal to 10 meters. So in this case, b is equal to 10 meters. And now that I know what b is, it becomes easier for me to apply the Pythagorean theorem to find a. Or I can also use cos to find this. But in this case, okay, now we know we can actually use Pythagorean theorem to find it, or we can also use cos to find it. So to find a, we can just apply the Pythagorean theorem, which states that for c squared must be a squared plus b squared. And in this case, applying it correctly, I will have that this is the hypotenuse, which is b squared, then a squared plus 5 squared. But then I know that this is 10. So I can replace b squared, b by 10. 10 squared is equal to a squared plus 5 squared, such that a squared is equal to 10 squared minus 5 squared. And I have that a squared must be 100 minus 25, such that a is equal to square root of 75. But then we can also break this down further by saying that a is the same thing as saying 3 times 25. And then I know that the square root of 25 is 5. Then I can then say that this answer is 5 square root of 3. So this is actually a solved operation. A is equal to 5 root 3. Then I also have to put my units. That's my final answer. So in this case, B is 10 meters, while A is 5 root 3.